Alpha decay equations by KayScience.com. The nucleus that I'm drawing here is the nucleus of a radium-226 isotope, a very radioactive, very unstable nucleus. So radium-226 has a relative atomic mass of 226 and it's got an atomic number of 88. We're going to look at what happens to the radium-226 nucleus after it has emitted an alpha particle. Because if it emits an alpha particle from the nucleus, that means it's going to have emitted 2 protons and 2 neutrons from its nucleus. That means its nucleus is going to get smaller. It's question time. Attempt these questions to check your understanding. So as we see here, the radium-226 has emitted an alpha particle. So an alpha particle has got 2 protons and 2 neutrons, which means that it's got a relative atomic mass of 4 and an atomic number of 2. So to work out what the new element is and the number of protons and neutrons, it's very simple. You simply subtract 4 from the relative atomic mass and you subtract 2 from the atomic number. And that gives you a new relative atomic mass of 222 and a new atomic number of 86. And that gives you a new relative atomic mass of 222 and a new atomic number of 86. So you would now look for the element with the atomic number 86 on the periodic table. And as you can see here, it is radon. It is radon. So the radioactive isotope radium-226 will undergo alpha decay, and when it does, it will form a new element, radon, which is more stable than radium. It's question time. Attempt these questions to check your understanding. I'm now going to go through another example using polonium-216, the radioactive isotope polonium-216. So polonium-216 has a relative atomic mass of 216 and an atomic number of 84. So if polonium-216 undergoes alpha decay, it's going to lose 2 protons and 2 neutrons from its nucleus. Because it's lost 2 protons and 2 neutrons, its relative atomic mass will go down by 4. That means that the number 216, you have to minus 4 from it. That will give you a new relative atomic mass of 212. The bottom number, the 2, represents the number of protons in the alpha particle. So now you subtract 2 from the atomic number, so it's going to be 84 minus 2. That gives you a new atomic number of 82. So what is the new element that has been formed? So you would now look for the element with the atomic number 82 on the periodic table. And as you can see here, an isotope of lead. That will give you a new relative atomic mass of 212. So it's going to be 84 minus 2. That gives you a new atomic number of 82, which is a more stable nucleus than polonium-216. It's question time. Attempt these questions to check your understanding. So to represent alpha decay, you start off with an element, in this case X, whereby the top number is the relative atomic mass, A, and the bottom number is the atomic number, Z. So we know that an alpha particle has a relative atomic mass of 4 and an atomic mass of 2. So this here is how you'd always write the alpha particle, 4, 2. To work out the new relative atomic mass of the new element Y, you subtract 4 from the relative atomic mass of X, and then you subtract 2 from the atomic number. And for alpha decay, it is always minus 4 from the top, minus 2 from the bottom. You must minus 4 from the top and 2 from the bottom. Press pause to practice using those key words. The answers will follow. Press pause to go through your answers and make any corrections to your mistakes. Press pause to answer the questions. The answers will follow. And if you're stuck, just re-watch the video. Press pause to go through your answers and make any corrections to your mistakes. Visit KayScience.com for more free videos, worksheets and quizzes at KayScience.com. And don't forget to like and subscribe.